Okay, in this lesson, we're going to take a closer look at some statistics, specifically central tendency and dispersion, and we're going to use our graphing calculators quite a bit here. Let's jump in and look at this first question. The table below shows the first quarter averages for Mr. Harper's statistics class. So here we have a table with two columns. The left column has quarter averages, the right column has frequencies. For example, there's only one person who made a 99 average, 7 students made a 90 average, 84 students made a 6 students made an 84 average. So you guys get the picture here. This is the frequency and this is the averages. What is the population variance for this set of data? Well, first thing we're going to do is we're going to plug all this into the calculator. So again, we go to Stat, Edit, and I'm just going to type in these values. And there we go. Got 12 or 11 in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I'll go ahead and populate the next column, L3, with the frequencies. And there we go. So, in this course, we're only going to be working with one variable, statistics. So I choose this, and on the Silver Edition, the list, for me, I plugged into L2 where the frequency occurred in L3. So if you're using the TI-84, or sorry, the TI-83, you want to plug it in like this: one variable stats, L1, comma L2. The second column will always be your frequency. If you used L2 and L3, obviously you change this to L2, L3. All right, let's calculate, and we end up with several statistics here. We have, and you scroll down, you can see it ends right here with the maximum X value of 99, and back up here we have our X bar, or our mean, of 88. So what do all these mean? Well, I'll show you. So X bar is the mean. Then we have sigma X is the sum of the X's. We have sum of the X squared. Sample standard deviation, population standard deviation, also known as the regular standard deviation. We have the minimum X, the maximum X, quartile 1, quartile 3, and the median. And to answer this question, what is the population variance? Well, the variance is defined as the standard deviation squared. So, let's go back and find our standard deviation. And there it is, 8.20432,937. And there's a shortcut to squaring that. I mean, you could just type in, 8.20, etc., then square it. Or what you could do is you go to the variable button, go down to statistics, and go ahead and choose the variable that you want. So here we have sigma X, and we square that, and there we go. The answer is 3. Okay, so at this point I would like to think back to a box and whisker plot. So here is, 0 to 100. You could say these are test scores. But the highest score was 100. The lowest score looks like about a 17 or 18. The median score was about a 68. And the lower quartile was about a 52, and the upper quartile was about a 87 or so. So remember, these are broken up into quartiles, meaning 25% of the scores occurred here, the next 25% is here, the next 25%, and the next 25% scores. So you could say the upper half of the scores were between 68 up to 100. The lower half of the scores were 67 and lower. And that you could really determine a lot of things by looking at this. I would like to take a look at this example here. The height in inches of 10 high school varsity basketball players are here. Find the interquartile range of this data set. Okay, so I'm going to use the calculator again. I'm going to plug them all in here. It's not a frequency table, so we're just going to plug them into one list. Choose one variable, statistics, and here's the important data that we need. Now, the old way to do this would be to basically list all these heights from least to greatest order, find the middle number, the median, and since we have 1, 2, 3, 4, 5, 1, 2, 3, there's 10 numbers, there is no middle number. So the middle number is actually the average of the two middle numbers. So the median would actually be 74.5. That is the median. And then the middle number of the lower half is Q1, quartile 1, and the middle number of the upper half of numbers is quartile 3. And the extreme would be max X, and the lower extreme would be min X. And I'm using all of these words here that are used that the calculator gives you. So if we go back into the calculator, we have min X, max X, median 74.5, Q1, and Q3. And to find the range, you guys remember the range is simply the max number minus the min number. So the range equals max X minus min X. And the interquartile range would be, as you guessed it, Q3 minus Q1. So, simple arithmetic. This would be 83 minus 71. So that's 12. The range is 12, but the interquartile range is 79 minus 72, which is 7. And the nice thing is that the calculator gives this all to you. 79 minus 72 is 7. Let's take a look at two more examples. So here we have some math tests and the frequency. Find the population standard deviation of these scores to the nearest 10. Well, I plugged in both of my lists. If you're using a TI-83 calculator, you want to type in 1 bar stats L1, L2. If you're using a TI-84, you want to type in the list number. Oh, that's what it was. On my calculator, this was L2, and the frequency list was L3. We hit calculate, and here we go. There are two standard deviations. The one that you want here is the population standard deviation. Okay, not to be confused with the sample standard deviation. Because we want to round to the nearest 10th, the answer is 7.4. Okay, now for the last question here. During a particular month, a local company surveyed all its employees to determine their travel times to work in minutes. The data for all 15 employees are shown below. Determine the number of employees whose travel time is within one standard deviation of the mean. So what we have to do is determine the standard deviation and the mean of this data here. So because it's one list, we type it all into one of those columns, hit one var stats, and here we have what we need. There's the mean, and there's the standard deviation. The mean is x hat, which is 40, x bar, and the standard deviation is sigma x, which is, I rounded it to 14.9. It's very important that you actually keep the decimal places because you'll see. Now, here is my normal curve. And if you recall, the very center is the median, or the mean. Okay, so the mean is 40. Now, one standard deviation above is 14.9 plus 40, which is 54.9. And one standard deviation below the mean is 40 minus 14.9, which is 25.1. So the question is, determine the number of employees whose travel time is within one standard deviation mean. That means plus one standard deviation and minus one standard deviation. So we're looking for the travel times that exist between 25.1 and 54.9. So this is simple, just looking through and saying, okay, is 25 between 25.1? No, it's too little. 45 is, 52 is, 55 is greater than 54.9. 30 falls between, 40 falls between, 35 does, 40 does, 29 does, and 37 does. Let's count these up. 1, 2, 3, 4, 5, 6, 7, 8. So the answer to the question is there are 8 commute times that exist between 25.1 and 54.9. And that is your summary of some of the things that the statistics function can allow you to do and determine on the graphing calculator, which should be very useful for this course. Good luck to you.